Assalamu alaikum. Midline Properties Part 4. At the end of this video, students will be able to recognize that in a trapezoid, the line segment passing through the midpoints of the non-parallel sides is parallel to its bases. Recognize that in a trapezoid, the line segment joining the midpoints of the non-parallel sides is equal to half the measure of the sum of the two bases. Materials: paper, pencil, ruler, compass, and your textbook edition 2017 or 2012. Lines joining the midpoints of a trapezoid. Remember, midline theorem in a trapezoid. In the trapezoid A, B, C, D, we have K is the midpoint of AD, D is a line parallel to AB and DC, then by midline theorem, R is the midpoint of BC. As we learned before, midline theorem needs one midpoint of the non-parallel side and a line passing through it parallel to the bases to get the second midpoint of the non-parallel sides. Converse of midline theorem in a trapezoid. Activity. In the adjacent figure, ABCD is a trapezoid. AB is equal to 4 cm, AD is equal to 3 cm, DC is equal to 6 cm, and ADC angle is equal to 50 degrees. 1. Reproduce the figure with exact measures. 2. Measure using protractor the angle AMN. 3a. Compare the measures of the angles AMN and ADC. B. Deduce the relative position of DC and MM. Please pause the video and try to solve the activity. Solution. 1 is the figure to the right. 2. Using a protractor, the angle AMN is equal to 50 degrees. 3a, AMN is equal to 50 degrees from part 2, and ADC is equal to 50 degrees from the given, so they are equal. B. Deduce the relative position of DC and MM. Since angle AMN and angle ADC are equal and they are corresponding angles, then the two lines are parallel. What do we conclude from this activity? As we see here in the activity, we have ABCD is any trapezoid, M is the midpoint of AD, and N is the midpoint of BC. What did we conclude? We concluded that MN is parallel to DC. So in any trapezoid, the line or the segment joining the midpoints of the two non-parallel sides of the trapezoid is parallel to the bases. It is parallel here to DC, and DC is parallel to AB, then the three segments are parallel. So the line or the segment joining the midpoints of the non-parallel sides of any trapezoid is parallel to the bases. Here is the general theorem. In a trapezoid, the line segment passing through the midpoints of the non-parallel sides is parallel to its bases, as we see here. K is the midpoint of AD, F is the midpoint of BC. So, by converse of midline theorem, AB, KF, and DC are parallel. Activity. ABCD is a trapezoid such that AB is parallel to DC, AB is equal to 5 cm, and DC is equal to 6 cm. K is the midpoint of AD, and F is the midpoint of BC. 1. What do we call KF? Segment KF. 2. Measure the length of KF. 3. Find AB plus DC over 2. 4. Compare KF and AB plus DC over 2. And 5. Complete. The line segment in a trapezoid joining the of the non-parallel sides is equal to the measure of the sum of the two bases. Please pause the video and try to solve this activity. Solution. What do we call KF? Since KF is the segment joining the midpoints of the non-parallel sides of a trapezoid, then KF is a midline. It is the line segment joining the midpoints of two segments of the trapezoid. Measure the length of KF. Using a ruler, we get KF is equal to 5.5 centimeter. Find AB plus DC over 2. The length of AB is equal to 5 from the given. The length of DC is equal to 6 centimeter from the given. So we get AB plus DC over 2 is equal to 5 plus 6 over 2, 11 over 2, which is 5.5 centimeter. Now, compare KF and AB plus DC over 2. Both are equal to 5.5 centimeter, then they are equal. 5 complete. The line segment in a trapezoid joining the midpoints of the non-parallel sides is equal to what? As we see here, KF is the midline, is the segment joining the midpoints of the non-parallel sides. It is equal to AB plus DC over 2. What is AB and what is DC? AB and DC are the bases of the trapezoid. So, the line segment in a trapezoid joining the midpoints of the non-parallel sides is equal to half the measure of the sum of the two bases. What property can we conclude from this activity? We can conclude that in any trapezoid, the segment joining the midpoints of the non-parallel sides of a trapezoid is equal to half the measure of the sum of the two bases of the trapezoid. Let's see if this can be generalized in any trapezoid using GeoGebra. Converse of midline theorem in trapezoid. ABED is a trapezoid, N is the midpoint of AD, and M is the midpoint of BE. We draw a line perpendicular to AB, and we notice that this line is also perpendicular to NM and DE at the same time. So 3 lines are perpendicular, or 3 segments are perpendicular to the same straight line, then the 3 segments are parallel. AB line is parallel to NM and parallel to DE. Hence, converse of midline theorem can be applied and generalized on any trapezoid, whatever the trapezoid is. The segment joining the midpoints of the two non-parallel sides of any trapezoid makes a line which is parallel to the bases of this trapezoid. Now we will move to the measure of NM, or the length of NM, and the ratio AB plus DE over 2. The length of AB plus the length of DE over 2. And as we see here, NM and AB plus DE over 2 are equal in measure, are equal. So, the size of this trapezoid, we notice that these two quantities are always equal. So what do we conclude? We conclude that NM is equal to AB plus DE over 2. If you change the segment joining the midpoints of the non-parallel sides of any trapezoid is equal to the measure of the sum of the bases over 2, or half the sum of the bases. Converse of midline theorem in a trapezoid. In a trapezoid, the line segment passing through the midpoints of the non-parallel sides is equal to half the measure of the sum of the two bases. In trapezoid ABCD, K is the midpoint of AD, F is the midpoint of BC, then KF is equal to the sum of AB and DC over 2. AB plus DC over 2. Application. In the adjacent figure, we have EFG is any triangle. K and L are the respective midpoints of EG and BF. AB is parallel to GF. EK is equal to 4.5 centimeter and EL is equal to 5 centimeter. Find the perimeter of triangle EKL. Let's remember, what is a perimeter of a triangle? It is the sum of its sides. Please pause the video and try to solve this application. Solution. First, perimeter of triangle EKL is the sum of its sides EK plus EL plus KL. So the perimeter of triangle EKL is equal to EK plus EL plus KL. EK is given 4.5 centimeter. EL is also given 5 centimeter. We have also AB is parallel to GF by given. Also AG and BF are non-parallel. So ABFG is what? Is a trapezoid. We have now a trapezoid, then we can use the midline theorem or the converse of midline theorem in a trapezoid. Here what do we have? From the given, we have K is the midpoint of AG and L is the midpoint of BF. Then we can use the converse of midline theorem in trapezoid, which says that the segment joining the midpoints of the non-parallel sides of the trapezoid is parallel to the bases and it is equal to half the sum of the lengths of the bases. So now we have K is the midpoint of AG by given, also L is the midpoint of BF by given. So by converse of midline theorem, KL is equal to AB plus GF over 2, which is equal to 2 plus 6 over 2. We have GF is equal to 6 centimeter and AB is equal to 2 centimeter by given, then it is equal to 8 over 2, 4 centimeter. Therefore, the perimeter of triangle EKL is equal to 4.5 plus 5 plus 4, which is equal to 13.5 centimeter. Assignment. Review from the textbook page 93 edition 2012 and page 97 edition 2017. Homework from the textbook exercise 1 part C page 96 edition 2012 and exercise 1 part C page 100 edition 2017. Summary. Midline theorem in a triangle. We have midpoint of the first side, a line passing through this midpoint and parallel to the second side. We get the point of intersection of this line with the third side is the midpoint of this side. Converse of midline theorem in a triangle. First midpoint, second midpoint, the line joining these midpoints is parallel to the third side. The line segment joining the midpoints of two sides of a triangle is equal to half the third side. Midline theorem in a trapezoid. We have one midpoint of the non-parallel sides of the trapezoid, a line passing through this midpoint and parallel to the bases. We get the second midpoint, which is the point of intersection of this line with the second non-parallel side. Converse of midline theorem in a trapezoid. We have two midpoints of the non-parallel sides of the trapezoid joined by a segment. This segment will be parallel to the bases. In a trapezoid, the line segment passing through the midpoints of the non-parallel sides is equal to half the measure of the sum of the two bases. Thank you for your attention.